Hello students, good evening everyone. I hope all are doing well. Anyway, warm welcome back all of you to the Infinity Learn JEE YouTube channel by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. I hope I am perfectly audible and visible to each and everyone present over here to watch this particular session. Okay, finally we are moving to the next part of our same chapter, solutions. The last class we have been seen about the solubility part, right? We have seen about the Henry's law. Hi Dhananjit, good evening, welcome to the session. I hope you guys have revised the topics we have covered in the last class. There is a small correction or small mistake I have taken from the last class. It is about that when we are talking about the Henry's law, I have already taught like that KH is directly proportional to solubility. So keep a note on that. It was not directly proportional to the Henry's constant. It is about the inversely proportional relation. So keep a note on that. Fine. So let us talk about the today's topic here, that is about the Raoult's law or the vapor pressure. Let's start. Okay, here is the first topic. What do you mean by vapor pressure? Is there any idea about that? What do you mean by vapor pressure? Hi Lakshay. Okay, we can just define the vapor pressure as the pressure exerted, right? It is the pressure exerted by the vapor molecules of a liquid when they are in equilibrium with the liquid at a given temperature. That is known as the vapor pressure. Let us see by an example here. For example, if I am taking a beaker here, this is our liquid. Let's assume this container is opened, right? So, for example, if I am taking the molecules here, right? There will be two types of molecules here. What do we call it as? Here, the molecules is present on the surface of the liquid. That is known as the surface molecules, right? Surface molecules. Then the particle or the molecules which is present inside the liquid is known as the bulk molecules. So what you are observing here, if I am applying heat over the container, what will be you observing? For example, if I am adding heat here, liquid will change its phase from liquid state to vapor phase, right? Gaseous state. So vapor forms. So the liquid molecules will escape easily as the vapor phase because it is an open container. Is that clear? Yes, it will evaporate, right? Yes, correct, Lakshay. So, if I am taking the same container in a different way, that I am closing the container. I am just closing the container. I am taking the same level of liquid here. Again, this is our surface molecule, right? This is the surface molecule. This is our bulk molecules. Similarly, if I am applying heat here, what you will observe? Whether the vapor escapes or not, because it is a closed container. Whether vapor escapes or not. Okay, it will start changing the phase from liquid to vapor, right? But here the container is closed. I can say that this vapor is exerting a pressure on it, right? This surface molecules or vapor will exert a pressure over it. So that particular pressure which is exerted by the surface molecules or the vapor molecules is known as the vapor pressure here. Is that clear? Is that clear? Just let me know in the comments. then what will happen to the bulk molecules? There will be the strong attraction here, right? In the case of bulk molecule, there will be strong force of attraction between the each side of the liquid particle. So, as compared to the surface molecules, there will not be any movement or the evaporation of the bulk molecules. Clear? Hi Jishan, good evening. Right. So now let us talk about the factors that affect in the vapor pressure. What are the factors that affect in the vapor pressure? Let's talk about the three factors. Start from the temperature. How temperature is affecting the vapor pressure? If I am applying heat, right? If I am increasing the temperature, what will happen to the vapor pressure? What will happen? Same case, right? I am taking a solution here, just giving heat. There will be our particles, right? So after applying heat, what will happen to the particles? Their kinetic energy increases, right? Their kinetic energy increases. So it will easily moves. So they easily escape as vapors, which means that vapor pressure is increases with increase in temperature, right? Yes, vapor pressure increases with the temperature, right? Which means that temperature is directly proportional to the vapor pressure. Clear? Is the point clear to everyone? How temperature is affecting the vapor pressure? Then what about the next parameter, next factor that is affecting the vapor pressure? Boiling point, right? I hope everyone had the idea about what you mean by boiling point. Those who are not aware about the boiling point, there will be a small definition for that. It is the particular temperature at which the vapor pressure become equal to the atmospheric pressure, right? Atmospheric pressure. That particular temperature is known as the boiling point of the particular compound, right? Yes, let us talk about the boiling point here first, then we can talk about the force of attraction, right? So what will happen to the vapor pressure if the boiling point, related to boiling point? Again, inversely proportional relationship, right? As the boiling point increases, vapor pressure decreases and vice versa. Thus, we can talk about with the effect of intermolecular forces, right? Intermolecular forces. For example, if I am taking any of the compound in which forces are very strong, right? Yes, it is inversely proportional, right? So, if any of the particle which is having the strong intermolecular forces, what will happen to the vapor pressure? For example, if I am giving heat, what will happen to the vapor pressure? Strong force of attraction, right? Strong force of attraction. So, we need more energy, right? We need more energy to get vaporized state. So, what will mean that? If it is a strong intermolecular force of attraction between the molecules, what will happen to the vapor pressure? Whether it is increases or decreases. Strong force of attraction. No answers? Yes, decreases, right? Otherwise, if you are talking about the intermolecular forces are very less, it can easily vaporizes, right? So, vapor pressure also high as case of intermolecular forces. As according to that, we can talk about the boiling point also. Is the point clear to everyone? Is it clear? Yes, fine. So these are the three parameters or the factors which connecting the vapor pressure here. First one, temperature. What will happen to the vapor pressure as the temperature increases? Directly proportional, right? As the temperature increases, vapor pressure also increases. Then again, boiling point, right? Boiling point is also inversely proportional to the vapor pressure. Then about the intermolecular force of attraction, right? Now let us talk about the vapor pressure of liquid-liquid solutions. How it is affecting the liquid-liquid solutions. Before that, we need to talk about what you mean by volatile liquids and non-volatile liquids. What do you mean by volatile liquids and non-volatile liquids? Can you please give me any of the example of volatile liquids? Or give me an idea that what you mean by volatile liquids. What the word volatile means. Those liquids which are vaporizes fast, right, which has a higher vapor pressure as compared to others is known as the volatile liquids. In terms of intermolecular forces, we can say that volatile liquids have very weak or very low intermolecular forces, right? So the liquids that is having the weaker intermolecular forces or attractions are having higher vapor pressure. Such liquids are known as volatile liquids, which is easily vaporizable, right? So what are the examples? Acetaldehyde, diethyl ether and pentene, for example kerosene. This is also an example of volatile liquids, right? So then what about the non-volatile liquids? Just reverse, right? Just opposite. Those liquids that have strong intermolecular force of attractions will have very low vapor pressure, right? Very low vapor pressure which cannot be easily vaporizable. So we can call these as the non-volatile liquids. For example, in the case of liquids, we can call it as mercury is a liquid, right? So mercury is considered as a non-volatile liquid. Clear? Is the point clear? Just let me know in the comments whether it is clear or not. Can I move to the next topic? This is a very important part of the solution chapter, that is about the Raoult's law. What do you mean by Raoult's law? Clear? Yes, fine. So here we will move into the very important topic. You may get more numerical problems based on this particular law only, Raoult's law. Okay, what will be the definition or what will be the idea about the Raoult's law? It is the first scientist, Raoult, who introduced the relationship between vapor pressure and the mole fraction of the liquids, right? So we can just define the Raoult's law as for a solution of volatile liquids, which means there will be a binary solution which contains two components, right? One is solute and solvent. Both the solute and solvent are liquid in nature, where they are volatile liquids, right? So in the case of that particular solution, the partial vapor pressure of each of the component is directly proportional to the mole fraction of the component which is present in the solution, right? For example, if I am taking any of the binary solution that is combining with solute A and solvent B, right? Okay, if a solution is made up of a solute A and solvent B, right? If you are considering here, according to Raoult's law, we can say that the partial vapor pressure, right? Partial vapor pressure of first component A, PA is directly proportional to the mole fraction. Mole fraction means chi of the particular component, right? Similarly, if you are talking about the component B, what will happen to the partial pressure here? PB is proportional to chi B, right? Or we can given as PA is equal to, there is a proportionality factor, right? So that is equal to PA0 into chi A, where PA0 is the partial pressure of the pure solvent. Clear? Similarly, PB is equal to PB0 into chi B, where PA0 is the clear? What do you mean by Raoult's law? Is the point clear? Yes. Now we need to do some small derivation about the vapor pressure of liquid-liquid solution. For that, we need to take a solution, right? We need to take a solution in which both the components are volatile, right? Both the components are volatile, which will form vapor above the solution. So, as I discussed earlier before, it's about the two miscible volatile liquids, right? We can call these as either A and B, two components A and B. So, it is having the mole fraction of chi A and chi B, right? Chi A and chi B. Suppose it is certain temperature, the partial vapor pressures are PA and PB, then the vapor pressures in the pure state as PA0 and PB0. Just giving the derivation, before that I am giving an idea about what you mean by the terms in the particular equation. Clear? Now let's talk about the derivation here. Okay, I see in this derivation, no need to worry, this is a simple calculation here. So, as we already know, the solution is made up of two components, right? A and B. So, if you are talking about the Raoult's law here, what is the partial pressure of A here? That is equal to chi A into PA0. That is the definition of Raoult's law, right? So, if you are considering about the first component A here, it will be the partial pressure PA is equal to chi A into PA0. Then what about the PB? Similarly, that is equal to chi B into PB0. Clear? Now, according to Dalton's law of partial pressure, we already know that the total pressure is equal to the sum of partial pressures of the individual components, right? According to Dalton's law. Total pressure is equal to the sum of partial pressures of A and B. So here it is given as PA is equal to chi A into PA0, right? So I am taking here P total is equal to chi A into PA0 plus chi B into PB0. Is that clear for everyone till here? Right? So I am writing P total is equal to chi A into PA0 plus chi B into PB0. Now what I am doing here, when I was discussing about the Henry's law or mole fraction, I have already taught like that. The sum of mole fractions of each component, that is if you are taking chi A plus chi B, that is equal to unity, right? Which means chi A plus chi B is equal to 1. So if I am taking this relation here, I can write these as chi A is equal to 1 minus chi B. Clear? Is there any doubt? Chi A is equal to 1 minus chi B. Is there any doubt? No, right? So, I am changing the value of chi A here as 1 minus chi B into PA0 plus chi B into PB0. Now, what you are observing here, if you are just solving here, you will get the answer as P total is equal to PB0 minus PA0 into chi B plus PA0. Clear? This is the last expression for the explanation of Raoult's law in the case of liquid-liquid solution. Clear? P total is equal to PB0 minus PA0 whole into chi B plus PA0. Is that clear? Then only we can move to the next part, that is the explanation of ideal solutions or the explanation of Raoult's law graph. Clear? Okay, fine. Now, here we need to talk about the representation of Raoult's law in terms of graph. There is a vapor pressure versus small fraction. Okay, what is our final expression for the Raoult's law here? In the case of liquid solution, P total is equal to P0, right? So, okay, Kuldeep, what is your doubt? Just let me know. Okay, I will come back to you. Let me talk about this graph here. So, if I am taking here the first component, right? First one, in the case of first case, the mole fraction of the first component, chi1 is taken as 1. Then what will be the mole fraction of the second component, chi2? What will be the value that? Zero, right? In total, chi1 plus chi2 is equal to 1. So, chi1 is equal to 1 here, chi2 is equal to 0, right? Then if you are talking about the chi1 here, what you are observing here, it gradually decreases, right? So, chi1 is equal to 0 here and chi2 is equal to 1 here, right? Then, let's talk about the expression here. If you are taking about the, let me write it as P10 minus, sorry, P20 minus P10 into chi B plus P10, right? Just taking the representation instead of A and B, I am taking it as 1 and 2, right? So, if I am taking the first case, chi1 is equal to 1 here, right? Chi1 is equal to 1 here. Chi1 is equal to 1 here and chi2 is equal to 0 here. Then what will be the expression for here, P total? What will be the expression for P total here? Chi2 will be 0, right? In total, P total is equal to P10. That is observing here like that. In the case of first case, the pressure will be P10 here. Is that clear? The maximum pressure will be P10 here. Then what about the next case? If the chi2 is equal to 1. If chi2 is equal to 1, what will be the value of P total? Should be P20, right? It should be P20. So you can observe here, the value will be P20 here. Clear? Clear how we can draw this graph? Just apply the value of chi1 and chi2 in the case of this particular equation, then you will get the P total as P10 in the case of first case and P20 in the case of second case, right? Then we can just draw like this, we will get the total pressure as equal to P total is equal to P1 plus P2. Is that clear? Is that clear? Okay, fine. So this is the explanation of ideal solutions. Ideal solution. We will be talking about the ideal solutions here. So in terms of ideal solution, we can say that this is the type of solutions in which it obeys Raoult's law, the entire composition. Clear? So this will be the graph for ideal solutions. Right? Okay, I hope it is clear for everyone how to draw the mole fraction versus vapor pressure graph for the ideal solution. Clear? Now let me practice some questions based on the Raoult's law. Here is the first question. Okay, try to find the answer for this question. It is given that 3 moles of ethanol and 1 mole of methanol are mixed together. Find the total pressure of the solution, and it is given as pure pressure of ethanol is given as 55 mmHg and pure pressure of methanol is given as 50 mmHg. Find out the vapor pressure for the final solution. Okay, what will be the answer for this question? Okay, how we can solve this according to Raoult's law, right? Number of moles is given here, 3 moles of ethanol mixed with 1 mole of methanol, right? So first we need to find out the mole fraction here. First I am taking the mole fraction of ethanol. How we can find out that? Number of moles of ethanol, right, which is given 3 divided by total number of moles of ethanol plus methanol, that will be 3 plus 1, that is equal to 3 by 4, right? Then what will be the mole fraction for methanol here? Either you can calculate by using number of moles, otherwise you can take the difference between 1 and 3 by 4, right? Then it will be equal to 1 by 4. Clear? Option A, right? Let's see what is the answer. So as we already mentioned about the mole fraction here. Now we can apply to the Raoult's law, right? Raoult's law. It is already given for ethanol, it is 55, right? So 55 into mole fraction is 3 by 4, right? 3 by 4 plus 50 into 1 by 4. So while solving here, you will get the answer is around 53.75. Clear? Which means option B will be the correct answer. Option 2 will be the correct answer. Is that clear now? Dharanjit? Is that clear now? You need to do the simple calculations here. First you have to calculate the mole fractions of each of the component and apply it on the Raoult's law. Do the normal calculations here. You will get the answer is around 53.75 mm of Hg. Clear? Now here is the next question. Okay. Again, the application of Raoult's law here. If 0.78 gram of benzene and 0.92 gram of toluene are mixed, find partial pressure of benzene and toluene and find out the total vapor pressure. It is already given. The partial vapor pressure of pure benzene and toluene are given here as 400 and 200 respectively. Just let me know the answers in the comments. The first step we have to follow that we need to find out the mole fraction of each of the component. Then apply it on the Raoult's law. You will get the answer of partial pressure of benzene and toluene here. Then just add the partial pressures. You will get the total pressure. Okay, what will be the answer for the first question? Partial pressure of benzene and toluene. What is the first step? You have to follow the mole fraction of benzene, right? Mole fraction of benzene. Okay, this is the number of moles of benzene here, right? 0.78 divided by 78 is the molecular mass of benzene. Whole divided by, again, number of moles of benzene plus number of moles of toluene here. While solving here, you will get the answer is around 1 by 2. This will be 0.01. This will be 0.01 plus 0.01. We'll get the answer is around 1 by 2 here. Then what will be the mole fraction of toluene here? No need of calculation, right? Take the difference between 1 and half, it will be again half. Then apply the Raoult's law here. (400 into 1 by 2) that is equal to 200. Then the partial pressure of toluene is equal to again half into 200, right? Half into 200 that is equal to 100. So this will be the answer for the first question, that is the partial pressures of benzene and toluene respectively. Then what will be this answer for second question? To find out the total vapor pressure. As than this you are correct, 100 mm of Hg, right? So total pressure P total is equal to the sum of first and second, that is equal to 200 plus 100, that is equal to 300, right? 300 mm of Hg. Clear? Clear? Here we move to the last question. Okay. The question is feel like little bit lengthy. Again, we need to apply the Raoult's law here. The question is, the total pressure observed by mixing two liquid A and B is 350 mm Hg when their mole fractions are 0.7 and 0.3 respectively. Then the next condition is that the total pressure becomes 410 mm Hg if the mole fractions are changed to 0.2 and 0.8 respectively. We need to find out the vapor pressure of pure A, which means we need to find out the value of PA0 here. This is the question asked in the JEE Main Shift 2 in the January 24, 2023. Sure? Option C is the correct answer. Did you do the calculations, Dhananjit? Okay, let us see what will be the answer. Option 2 will be the correct answer here. Here you need to do small mathematical calculations here, right? So first case, what is the first case given here? Total pressure will be given as 350 mm Hg, right? So I can written it as 350 mm Hg is equal to 0.7 into PA0 plus 0.3 into PB0, right? Is there any doubt? It's already given in the data. So this is our first equation. Then in the next part, it is shown that if you are changing the mole fraction from 0.2 to 0.8, the value will become 410, right? 410. By solving this equation, you need to find out the value of PA0 here, right? PA0 here. What you have to do? Just multiply this equation with 8. Then again multiplying this second equation with 3. Now take the difference, you will get the value is around . Clear? Just take the calculations and you will get the answer is around 314 mm of Hg, which is the pure pressure of the pure component A, PA0. Is that clear? Okay, fine. Now let us talk about the other conditions for the Raoult's law. We have to talk about what you mean by ideal solutions and non-ideal solutions, right? As we already seen about the graph here, in the case of ideal solutions, these are the particular solutions in which it always obeys the Raoult's law under any conditions of concentration, right? Any compositions. So we can just define the solutions as which obeys Raoult's law, over the entire range of concentration. Entire range of composition is known as the ideal solution. We have already seen about the graph there. Vapor pressure was a small fraction for the component. Clear? So what will be the conditions for that? If you are talking about the volume of mixing, we can say that in the case of ideal solution, if you are mixing any of the two components, you will get the total volume as the same, which means that delta V mixing is equal to 0. For example, if I am talking about the benzene and toluene here, right? If I am taking 50 centimeter cube of benzene with 50 centimeter cube of toluene, what you are observing here, you will get a total of 100 centimeter cube of volume in the case of particular solution, right? Which means that total volume before the component is equal to the total volume after the formation of solution, right? So delta V mixing is equal to 0 in the case of ideal solution. Is that clear? So delta V mixing is also 0. Then if you are talking about the heat exchange there, we can say that delta H mixing is equal to 0, which means that if you are talking about the ideal solution, there will not be any change of heat there. There is no heat absorption or heat liberation in the case of ideal solutions. So that is the condition for ideal solutions. In general, these ideal solutions are rare. Is that clear? Is that clear? Yes. Now what about non-ideal solutions? What will be the condition for the non-ideal solutions? And these are the examples which is given in your NCERT. Just refer this. Benzene plus toluene, hexane plus heptene, ethyl bromide plus ethyl chloride, chlorobenzene plus bromobenzene are the examples of ideal solutions. So this is very important. Examples are very important in case of JEE Main memory based questions. Right? Then what do you mean by non-ideal solutions? Non-ideal solutions. Just opposite that, right? Any of the solutions which does not obey Raoult's law at the entire range of composition or concentration are known as non-ideal solutions. It does not obey Raoult's law, right? These particular solutions are known as non-ideal solution. In this particular case, we need to talk about the positive as well as negative deviation. What do you mean by positive or negative deviation? Any idea? In general, according to Raoult's law, the pressure should be equal to the partial pressure of pure component into mole fraction, right? So, if you are talking about the positive deviation, the expected vapor pressure is higher than that of the real one, right? So, that will be the positive deviation. If the vapor pressure expected is less than that of the real one, it will be negative deviation. So, what will be the condition for here? In the case of ideal solution, delta V mixing is equal to 0, right? But here in the case of non-ideal solution, delta V mixing is not equal to 0 as well as delta H mixing not equal to 0. Let us take an example here. If you are adding a few amount of sulfuric acid to the water, what you are observing here, there will be heat formed, right? Because acid plus water reaction is an exothermic reaction. A heat is forming here, right? A very large of heat is forming here. And if you are talking about the volume change, we can say that there will be a change in volume, which means that it is a type of non-ideal solutions in which delta H mixing is not equal to 0 as well as delta V mixing is not equal to 0. Is that clear? That will be the condition for non-ideal solutions. Right. Now let us again talk about the graph here in the case of positive deviation, right? Positive deviation. Okay, what you are observing here, this is our real case, right? These dotted lines are the real case of ideal solution. So what you are observing here, this is the vapor pressure, right? This is the vapor pressure, which means that this vapor pressure is always higher than that expected from the Raoult's law. That is why it is showing the positive deviation. What will be the reason behind that? What will be the reason behind that in terms of intermolecular force of attraction? Let's say Raoult's law is applicable to the liquid solution, right? If you are combining with the two components A and B, let's say this is our component. solution, right? So it will form by the combination of A, B, right? A, B. Right. If we are talking about the intermolecular force of attraction here, in the case of these particular reactions, we can say that this force of attraction, right, there will be the force of attraction between the solute molecules, AA molecules, as well as solvent molecules, BB interaction, right? These AA-BB interactions are more stronger than as compared to AB interactions. Or we can say that this is a solution in which A and B are the solute and solvent respectively. In the case of solution phase, the interaction between A and B are very weak, right? A and B are very weak. So what will happen to the vapor pressure? The case of solution, this intermolecular force of attraction between solute and solvent is very weak, right? So you can easily escape out, right? By solute molecules or solvent molecules, we can just escape out the particles from the solution side. So what will happen to the vapor pressure? Vapor pressure also increases, right? Are you getting my point? So that vapor pressure increases, right? So that is the reason behind that. In the case of non-ideal solutions, it is showing positive deviation. As we are explaining vapor pressure like this, but we are getting a higher vapor pressure as compared to the Raoult's law. Clear? Now, what will be the reason for negative deviation? What is happening to the interaction between these molecules in case of negative deviation? In the case of negative deviation, this AB strength are very strong, right? So we cannot easily escape the particles from the solution side. So that vapor pressure decreases in the case of negative deviation, right? Clear? Again, we need to focus on the conditions here in the case of positive deviation. As we already know, the pressure of A is greater than chi A into PA0, or P total is always greater than, vapor pressure is always greater than the expected one, right? That is the first condition for the positive deviation. Then what will happen to the delta H mixing? It should be higher, right? It should be higher, or called as positive in the case of positive deviation. It will be delta H mixing as well as delta V mixing is equal to positive, right? Again, we need to focus on the examples here. These are the given examples in the NCERT textbook. Acetone plus carbon disulfide, acetone plus ethyl alcohol, acetone plus benzene, and methyl alcohol plus water. Clear? For the positive deviation. Then what will be the condition for the negative deviation? Again, the dotted line is our expected Raoult's law graph, right, for the ideal solution, right? So here you are observing that vapor pressure is low as compared to the Raoult's law because of very strong interaction between the AB molecules as compared to the AA and BB interaction, right? So there will be a strong force of attraction. It is not easy to escape the particles from the solution side, so that vapor pressure decreases, right? Vapor pressure decreases. That is the reason behind the negative deviation shown by the sum of the solutions. Clear? Is that clear? Yes, again the conditions given here, just opposite that of the positive deviation. What will happen to the total pressure? It is less than that of the pressure expected from the Raoult's law, right? Then delta H mixing and delta V mixing is equal to negative here. Again, some of the examples given here: chloroform plus benzene, chloroform plus diethyl ether, acetone plus aniline, HCl plus water, nitric acid plus water, acetic acid plus pyridine. These are the examples of non-ideal solutions shown by the negative deviation, which is given in the NCERT. Clear? So this is a little summary about the ideal and non-ideal solutions here. As I already mentioned, so you can see over here, this is the ideal solutions having the Raoult's law condition as well as intermolecular interaction and their examples. The second part is about the non-ideal solutions with positive and negative deviation. Clear? Again, the same image which is given in the case of NCERT textbook. Just refer about this. Okay, that's all about from my side for today. We have discussed about the Raoult's law, right? We are starting from the vapor pressure. What do you mean by vapor pressure? How this vapor pressure is affecting in the case of liquid-liquid solution. We have seen about the Raoult's law, right? As a part of Raoult's law, we have seen about the ideal solutions, non-ideal solutions with positive and negative deviation, right? I hope it is clear. It was clear for everyone. If you have any doubt, you can ask otherwise. Otherwise, we can wind up the session for today. Hi Siddhan, congratulations. Okay, there is a gentle reminder about the AATS. Finally, the JEE Main exams are over. The next phase is our JEE Advanced 2025, right? So Infinity Learning is providing you an all-day test series for that. So just enroll fast. Again, there is another opportunity for the college predictor. You must have idea about your JEE Main scores, right? So you can give me your JEE Main scores in the case of college predictor. Then you will get an idea about the list of colleges that you will get about your JEE Main scores. The link will be provided in the description. You can just enter your score there, right? Then the last opportunity is about those who are not getting any good ranks in the JEE Main exams. That's about the private exams. Again, Infinity Learn is giving an opportunity to find out solve the private engineering exams here. You will get a 70% off by using the first 70 off code using here. So enroll fast. Don't miss the opportunity here. Okay, I hope it was clear for everyone. Thank you so much from my side. If you really like the session, just hit the like button, share this particular session to your friends and family. Subscribe our channel for more updates. Then you will get the session PDF in our Telegram channel. You can join our Infinity Learn JEE Telegram channel. Okay, till then, bye-bye all of you. Thank you so much. See you in the next session. I will be coming back with the next part of solutions by using the assiotropes and the ideal and non-ideal solutions with examples, with problems. Till then, bye-bye all of you. Thank you so much. Take care.